So we could say that the two objects are related if they're both the same color. In other words, this object up here would be related to this object because it's red, and of course this object would end up being related to this object. Tons of ways to define things. You could, let's say there was an object here and an object over here. And let's say that they were at some particular angle. Okay, you could say that these two objects, or object 1 is related to object 2 if object 1 is to the left of object 2 and at some particular angle. Okay, but is object 2 related to object 1? No. Okay, in other words, I'm reading this as like this object here would be related to this object here. Okay, that's the way I'm reading that. So you'd write this ordered pair, but we define it as being to the left, and let's say at some angle 45 degrees here. Let's say from the horizon or something. Anyway, man, there's every kind of way you can imagine to define a relationship. Anyhow, let's get back to the math here, even though that is math. Believe it or not, that's math. Let's clear the whiteboard. And let's look at something else here. I really like to talk a lot about that. I could probably write a dissertation on that, especially when it comes to drawing treasure maps or just art in general, that you're trying to convey some secret message to somebody. And if they know the relation, only they will understand it. All right, let's look at this. Now I'm going to write this as a set of ordered pairs here, and I'm going to look at this relationship here. And of course we're keeping these nice and short. You know, there could be an infinite number of ordered pairs in here. This particular relationship, this is a special kind of relationship, and this relationship is a function. Okay, and here's the reason why. These numbers, these first coordinates here, are all different. Notice all the first coordinates are different. And if these are all different, we can consider this relation to be a function, as long as these are all different. Okay, we don't care about the second coordinate. Alright, second coordinates could be the same, but if the first coordinates are all different, then this is a special kind of relation, and this relation is known as a function, and this is of course what we're going to mostly be working with from here on out. Now I'm going to write up two sets here. This is going to be the set with 1, 2, 3, 4, ... let's say up to 10. Put 10 in here, and then we'll call this the set Y, and it has, let's see if you can see a pattern. There's a pattern going on here. Okay, and I'm going to once again just label this, what should I label this? I'm going to label this as SQ. And what I'm going to do now is the first coordinate is going to come from the set X, and the second coordinate is going to come from the set Y. So this is related to this. Let's see if you can figure this out. 2 is related to 4. Okay. 3 is related to 9. 4 is related to 16. Now we got some other ordered pairs in between here, and then the last one is going to be 10 is related to 100. Now let's close this up. Okay, this relation is a function. Right? This relation is a function because look, all of our first coordinates are all going to be different, even though I didn't write these in, but look at the pattern. Now we can actually represent this by this equation here.